Imagine a colossal cargo ship gliding effortlessly across a vast ocean. But here's the twist. There's not a single soul on the bridge. Instead, an advanced artificial intelligence system, a silent captain, charts the course, monitors the engine room, and makes split-second decisions to ensure a safe and efficient voyage. This is not a scene from a science fiction movie. This is the future of maritime transportation, the era of smart ships. Artificial intelligence, or AI, is rapidly transforming various sectors, and marine engineering is no exception. From optimizing ship design to revolutionizing navigation and enhancing safety protocols, AI is poised to make waves in the maritime industry. This essay explores the multifaceted role of AI in developing smart ships and examines the profound impact this technological revolution will have on global trade, environmental sustainability, and the future of seafaring. The integration of AI in marine engineering marks a paradigm shift in an industry steeped in tradition. By leveraging the power of machine learning, data analytics, and intelligent automation, smart ships promise to usher in a new era of safer, cleaner, and more efficient maritime operations. As we delve deeper into the world of AI-driven ships, we'll uncover the exciting possibilities and transformative potential that lie ahead for the future of seafaring. At the heart of every smart ship is a sophisticated AI system that acts as its digital brain. This system comprises an intricate network of sensors, algorithms, and data processing units that work in unison to collect, analyze, and interpret vast amounts of data from various sources. This data-driven approach empowers smart ships to make informed decisions, optimize performance, and adapt to changing conditions at sea. One of the most prominent roles of AI in smart ships is in navigation. AI-powered navigation systems can process real-time data from GPS, radar, and other sensors to create a comprehensive picture of the vessel's surroundings. This allows for precise route optimization, collision avoidance, and efficient maneuvering in congested waterways. Moreover, AI algorithms can analyze historical and real-time weather data to predict and adapt to changing sea conditions. This proactive approach to navigation ensures smoother sailing, reduces fuel consumption, and minimizes the risk of delays or accidents caused by adverse weather. By automating and optimizing navigation, AI empowers smart ships to navigate the seas with unprecedented precision and efficiency. Safety is paramount in the maritime industry, and AI is playing an increasingly vital role in enhancing safety protocols on smart ships. AI-powered systems can monitor the ship's structural integrity, detect potential hazards, and alert the crew to any anomalies or potential risks. For instance, AI algorithms can analyze data from sensors placed throughout the ship to identify signs of metal fatigue, corrosion, or structural stress. This early detection system allows for timely maintenance and repairs, preventing catastrophic failures at sea. Furthermore, AI can monitor the ship's stability, balance, and cargo distribution, ensuring the vessel remains seaworthy even in challenging conditions. In addition to monitoring the ship's health, AI also enhances safety by improving situational awareness. AI-powered surveillance systems can detect and track other vessels, obstacles, and even potential threats like pirates or smugglers. This enhanced awareness allows the crew to